Nowadays, many power tool manufacturers prefer analog front-end ICs. Except power tools, we can also find them in battery packs of gardening tools, robot lawn mowers, vacuum cleaners, power banks, etc. Now, let us begin to explain what is the significant difference between so-called standalone and analog front-end protection solutions. Standalone protection ICs are widely used in the market. They perform all tasks such as cell voltage and current monitoring, the decision to interrupt the charge and discharge process in case of critical event, and controlling the external dual MOSFET transistors. An analog front-end IC is actually a measurement IC only and forwards the measurement results to an MCU processor IC. The software of the MCU contains all the threshold monitoring settings algorithms and decides to interrupt the charge and discharge process of cells. It also controls the dual MOSFETs directly or indirectly. Especially for large battery packs, it becomes more difficult for engineers to work with internally fixed settings like in standalone solutions. There is no possibility to make changes in the settings and algorithms, as this is all pre-programmed into the standalone IC. In case any modification in settings should be made, a different version of the IC should be ordered, which delays the development time significantly. An analog front-end IC is much more flexible, as the MCU software can be changed at any time. This kind of solution saves time to market, which is often a key advantage. Currently, we have two AFE ICs in our portfolio, the R5601 and R5602. Both have their advantages, which are highlighted in the comparison chart. Our first AFE, R5601, is designed to protect 3 to 5 cells. The R5602 protects 4 to 7 cell battery packs. Another major difference is that the R5601 has no integrated analog-digital converter and has to rely on external MCU with embedded analog-digital converter. As a result, the R5601 has two analog outputs for voltage and current measurement. The R5602 has an integrated analog-digital converter, and therefore it can also be called a digital front-end IC. Measurement results are transferred throughout an I2C or SPI interface. Note that R5602 has high-side MOSFETs, whereas the R5601 has low-side MOSFETs. It's very common for lithium-ion protection ICs to use a low-side solution, but customers made remarks that it can cause some offset measurement issues since the GND terminals of the AFE and MCU are not shared. Although driving the high-side MOSFETs is more complicated by use of an additional internal charge pump circuit, the advantage is very obvious. Power tools may experience harsh operating conditions and should have some extra safety measures for this. Internal wires of the battery pack may break when a tool drops on the floor or due to extreme vibrations. The 5602 has a feature to detect open wires and avoids a maloperation of the safety circuits of the battery pack. The R5601 does not have such safety feature. The R5602 allows a random cell connection sequence to simplify the manufacturing process of battery pack. Products without this feature, like R5601, have a strict cell connection sequence during the assembly of battery pack. When not following the connection instructions, it may cause a permanent failure of the IC. When a battery pack is designed using multiple cells in series, it's essential to design the system in such a way that the cell voltages are balanced in order to optimize performance and life cycles. It's known that no two cells are identical in nature, even if they are from the same manufacturer and are of the exact same model. There are slight differences in each cell's characteristics, like the state of charge, impedance, capacity, or temperature characteristics. When a cell unbalance is detected, the R5601 and R5602, a balancing technique is used of discharging the cells through a bypass road, and excessive charge is dissipated as heat. The AFE ICs have internal switches and resistors to bypass the deficient cell. Various power tool manufacturers adapted our AFE ICs as they provide a rock-solid solution for their requirements. Even though the AFE ICs are one of the most advanced and versatile solutions, some manufacturers still prefer the traditional way with standalone protection ICs, as it offers advantages like a simple design and more cost-efficient solution. Please be advised that we also have a solution for standalone protection ICs. Have a look to our complete portfolio of battery protection ICs on our website, and perhaps you may become inspired to use one of our products in your next design.